Have you ever held a piece of history? I mean, a really old piece of history? What if I told you that you could hold something older than any civilization, older than the Earth itself, heck, older than our own sun? Well, stick with me because we are about to solve a mystery that's literally written in stardust.
That's right, it's not science fiction. Scattered inside meteorites that land on our planet are these microscopic time travelers, grains of dust that were forged inside stars that died long before our solar system was even a twinkle in the cosmos. These are actual relics from a lost generation of stars, and they hold the secrets of what came before us.
And get this, some of the absolute coolest of these grains are called pre-solar graphite onions. They're like these perfect little cosmic time capsules. Picture a tiny, tiny ball of pure carbon. Right at its heart, you've got this messy, jumbled up center. But wrapped around it, layer after perfect layer, are these beautiful shells of graphite, just like an onion. So the question is, how in the world did they get this strange, super specific structure?
And that brings us to the puzzle of these cosmic onions. Their very existence, this perfect yet imperfect structure, is a huge clue that points back to some really mysterious origins. So yeah, that's the big question, right? What kind of cosmic furnace could possibly forge something so delicate and so peculiar? And what kind of process creates that messy core but then switches to building a perfect outer shell? To answer that, we have to go looking for clues at a very, very old crime scene.
So our investigation is going to take us hundreds of light years away and billions of years back in time, to the atmosphere of a star at the very end of its life.
The number one suspect is a type of star called an asymptotic giant branch star, or let's just call them AGB stars. It's way easier. These are old dying stars that swell up and start puffing their carbon-rich outer layers out into space. And for a long time, scientists have believed it was in this chaotic, cooling stellar wind that our cosmic onions were born.
So here's the theory, the recipe, if you will. First, in the cooling atmosphere of that dying star, carbon gas condenses into a tiny, supercooled liquid droplet. Then, bam! That droplet freezes solid so fast the atoms have no time to line up neatly. That's how you get the messy core. After that, as things cool down more slowly, individual carbon atoms start sticking to that core one by one, carefully building those perfect outer layers. It's a beautiful theory, right? Except for one massive problem.
There was a huge roadblock. You see, it's one thing to have a great theory, but it's a whole other thing to prove it when your laboratory is a star that died billions of years ago.
I mean, think about it. That's the core of the problem. We can't just send a probe to an AGB star or grab some samples. So for the longest time, there was just no way to know for sure if this is how these cosmic onions are really made.
So what did scientists do? They turned to computer simulations. But here's the catch. As you can see on the left, computers have to run these simulations incredibly fast. We're talking picoseconds. But in nature, which you see on the right, the process happening in those gentle stellar winds is much, much slower. And every single time, the super fast computer models failed. They could never create that signature messy core.
So it became pretty clear that the speed of cooling wasn't just part of the recipe, it was the secret sauce. That slow, gentle process was the key. But trying to recreate that kind of slow, high-temperature environment right here on Earth, it seemed pretty much impossible, until a team of scientists had a truly brilliant idea.
The idea was simple, really. If you can't go to the star, why not bring a tiny piece of the star into your lab? This is where some real ingenuity comes into play.
So, a team of researchers at the University of Missouri-St. Louis decided to tackle this problem head-on. They built a completely custom piece of equipment, basically a miniature oven designed to perfectly mimic the conditions inside a dying star's atmosphere, right there in their lab. Okay, so here's the breakdown of their star in a jar. First off, it's tiny, just over 6 millimeters across, and it's made of graphite. They heat this thing up to over 3,000 Kelvin, which is hot enough to create a dense cloud of carbon vapor inside. But here's the crucial part. Because it's a tiny, closed space, that vapor gets trapped. It can't just expand and cool instantly. And that little detail gave them the secret ingredient: controlled, slower cooling, just like what you'd find in the atmosphere of a star.
So they built their little star in a jar. They cranked up the heat, created a cloud of carbon vapor, and then they let it cool. The stage was officially set to either prove, or completely disprove, a decades-old cosmic theory.
This is it. The moment of truth. After all that work, after building this incredible custom device, did they actually manage to cook up a batch of ancient stardust right here on Earth?
You better believe it. Yes, they did it. When they looked at their samples under a powerful electron microscope, they found them. Tiny, perfectly formed artificial graphite onions. They had actually done it.
And the results were just definitive. The onions they made were the perfect size, between 0.1 and 0.4 microns across. But most importantly, they had that signature messy core and the perfectly layered rim. They were a perfect structural match for the real stardust found in meteorites. The experiment was a huge success, and it physically proved that slow cooling was the key all along.
I mean, here's what the scientists themselves said in their paper. They basically confirmed that, yep, their method worked. They didn't just create the onions, they opened up a whole new way to study how they form just by controlling the cooling rate right there in the lab.
And you've got to understand, this is so much bigger than just making some tiny carbon balls. This wasn't just a cool science experiment. By solving this mystery, these scientists gave us real, physical proof of how carbon, the fundamental building block of life, of planets, of us, was forged in ancient stars and then spread across the galaxy.
So the next time you look up at the night sky, remember that it's not just empty space. It's a library, and the books are microscopic grains of dust from long-dead stars. And we are just now, finally, learning how to read them. And in doing so, we're learning how to read our own cosmic origin story. It just makes you wonder, what other secrets are waiting for us inside a fallen star?